I feel like we've been talking about graphing sine and cosine for a long time with our snow days and cold days and practice ACT and all of that other stuff. But we're finally going to get to graph them today. Yay. Okay. And I've been telling you that we're going to do it with this method called the framing method. So let's just remind ourselves what our parent functions look like. This is something that should be in your notes from the day before, even though it was like Friday, right? I don't even know when we took these notes. Okay, Friday, right? Okay. So y equals the sine of x starts at the origin and makes kind of an S shape bouncing between -1 and 1. It has an amplitude of 1, period of 2 pi. Okay? And then the parent function for cosine of x, it starts up at 0, 1, and then it dips down kind of like a valley. Okay? Once again, amplitude of 1, period of 2 pi. Okay? Now, sine and cosine have some similar properties, right? They both bounce in between two values. They have sort of the same shape. They just kind of start in different places. So what we're going to do is we're going to take this 1 period and we're going to frame it. Okay? So if we can draw a frame, then we'll be able to put our curve in there. Okay? So this is what's going to happen. We are going to have a starting point. That starting point tells us how to draw our frame. We will draw our frame up and down the amplitude. Okay? We'll draw our frame over however long the period is. And then we will break it up in half and then in quarters. I'll tell you why here in a moment. But what I'd like you to do is go ahead and draw this in your notes. This is how we create our frame. We first plot the starting point. We draw the left side up the amplitude and down the amplitude, and then over the period. Horizontally, we cut it in half. Vertically, we cut it into fourths. Good morning. Okay, so we know that our curve, the amplitude describes half of the vertical height. So if we go up and down the amplitude, okay, double the amplitude is the total height, okay? And then we know that we want, well, really we're going to focus on 1 period. So we're going to draw that frame, whatever the period is, okay? And then we need to be able to fit that curve in, okay? So I'm going to show you why I do this in a minute, but when we split it in half, horizontally, okay, we can kind of see where what would be the x-axis is. Obviously, it's going to move from there, okay? And then we're going to split it in half and then into fourths vertically so we know where to put our 5 important coordinates, okay? So I've given you a blue handout. I want you to get that handout. What you might end up doing is like taping it in your notes, and that's fine. If you'd like to do that, like leave space in your notebook and then tape it in. I have tape, staplers, whatever. Okay. But I want you to have something to reference and not have to write all of this down. Okay. So I want you to go to the bottom. We're going to make some pictures. Okay. Let's think about what our sine graph looks like. Okay. Our sine graph starts at the origin. Do you agree? Yes. Okay. Our sine graph starts at the origin, and then it goes up, and then it falls, and then we come back to where we start. So I want you to make these 5 important coordinates on your sine with a positive A. Okay? That way, if we have any sort of translation or stretch or shrink, if we have our frame, we can just draw these 5 coordinates in our frame. Notice how each of the 5 coordinates come at an intersection at our frame. Okay? We're either on the top, middle, or bottom of our frame, and then each of these quarter marks is where a coordinate would go. Okay? Now, sine with a negative A. We're going to start at the same place, but when we go to the first quarter mark, where should we go? We should go down because we have a reflection. Each quarter mark is where the coordinates go, nowhere else. Okay, now cosine. Does cosine start at the origin? No. It does not. Okay? Our starting point is not telling us where our curve starts. It's telling us where our frame starts. If we were to go back to our cosine curve and we were to draw a frame around it, oops, it starts way up here in the corner. Do you see that? Okay? So what we are going to do is with a cosine curve with a positive A, we need to start in the top corner. The starting point is where we start our frame, but the first coordinate is actually going to go in the corner. And then we know that the cosine curve looks like a valley. So at each quarter mark, I'm going to decrease and then increase so that we can get that shape. All right, let's think about this. If we have a negative A in front of our cosine and we have a reflection, where would we put our first coordinate in that case? The bottom. If we have a negative A, which means we have a reflection, this is going to flip upside down. So we would need to start in the bottom corner. So it should look more like a hill. Okay, make sure everything is nice and curved. There's no points. Okay, also kind of notice how we have to start curving to turn back up or down, depending. Okay, with cosine, we have to kind of imagine that continuing on. Okay. Okay. The reason I have you do this framing method is so that it takes all the guess out of those stretches and shifts. Okay? If we can find our starting point, which you've already practiced, Dallas and Max, you were distracted. Not to mention everyone else. If you can find the starting point and draw your frame, and you know what your curve looks like, okay, we don't have to think quite as hard about it. Okay? So at the top of your blue paper, let's just go through what our method is going to be. Okay, let's put all of the pieces together. I've already taught you how to find the starting point, right? C over B comma D. You're going to plot that. And I'm actually not going to give you graph paper. Okay? You're just going to plot it. And we're going to figure out everything from there. Okay? Then we're going to identify the amplitude, okay? We will draw up and down the amplitude. So if we know where our starting point is and we draw our frame, we know the extremes of our frame, right? If we start at 2, we start at a y value of 2 and our amplitude is 3, we would know we would go up to 5 and down to -1. Okay, we know where we are on the coordinate plane. Okay. The period we calculate by 2 pi over b. You've already practiced that. So then you're going to construct your frame up at amplitude, down amplitude, just like you drew out, over the period. Then you're going to have to come up with all of the x values of those quarter marks. Okay? Now, if you know where your frame begins and you know what the period is, we can use addition to figure out where it stops. Okay? Now, there's going to be 2 different ways we're going to figure out what those quarter marks are. The first thing you can do is figure out where your frame starts and where it stops. Find the midpoint for the middle, and then using that and the end, find that midpoint for the quarter mark. Find the middle and the beginning and find that midpoint. Okay? If that doesn't sound like what you want to do, then you could take the period, cut it into fourths, and just add a fourth of the period each time for those quarter marks. I'll show you what both of those look like. Okay? Now, why am I making a big deal of this? I expect you to label your 5 critical points. So the 5 points that we put inside of our frame for each of the sine and cosine graphs, you're going to go back in and give me the x, y coordinates of each of those. So it's important that we have our frame labeled so we can go back and identify the coordinates. Okay? So, my hope is that we're going to do 3 examples today. 1 cosine, 1 sine, and I can't remember what the third one is. Okay? So, this is where you're going to go back to your notebook. Go ahead and write this example down. And I'm going to give you a minute to write it down and identify amplitude, period, and starting point. Okay. Consult your neighbor to check your amplitude, period, and starting point. Kinley, what's our amplitude?
1, but it's reflected.
Okay, we have an amplitude of 1, but we better make a note to ourselves that we have a reflected sine graph. Okay, good. The period, Jessica, what is it? 2 pi. B is 1, so our period is just 2 pi, which is nice. Okay. Austin, what's our starting point?
Negative pi over 2, comma 3.
Negative pi over 2, comma 3. Max, why is it negative pi over 2?
Because it's inside of the parentheses, so it's reversed.
Okay, we're inside the parentheses, so that plus pi over 2 is a shift to the left. Okay? All right, so when you construct your frame, I want you to do it very lightly. Okay, so when you're using your pencil, it's going to be light. The frame isn't actually a part of our graph. It's just a tool to help us fit the coordinates in. Okay, so our starting point is negative pi over 2, comma 3. Okay, if our amplitude is 1, then we would draw our frame up to 4 and down to 2. If our y value is 3 and our amplitude is 1, we would draw up 1 to 4 and down 1 to 2. Okay. I went ahead and drew my frame. If our period is 2 pi, and we begin at x equals negative pi over 2, where does our frame stop? It begins at negative pi over 2. Who said that? Okay, Max, how did you get pi over 2?
3 pi over 2, that's what
You said 3 pi over 2.
Because it's 2 pi, but then we subtract 1 half pi.
So we're beginning at negative pi over 2, and we drew the length of 2 pi. So if we start at negative pi over 2 and we add 2 pi, we get to 3 pi over 2. Does that make sense? So we took the x of our starting point and we added the period. Okay, just so you need that note. Okay. So now, and this is probably the most rigorous part of our process. Once we get the frame constructed, it's just putting points in, okay? And you've all had practice of doing all the identification, so drawing the frame is the big part, okay? So I'm going to split it in half, okay? Now we need to split our frame vertically into fourths. So the first thing that we can do is we can split it in half. Okay, well, if I begin at negative pi over 2 and I end at 3 pi over 2, what's the midpoint for that? Okay, Dallas, you're shaking your head. How did he get pi over 2?
We just did 1 pi plus negative 1 half pi. Negative pi over 1 half. Negative pi over 2. Wow. Jeez.
Okay, to find a midpoint, we take the values and add them and then cut them in half. Okay, so if we take negative pi over 2 plus 3 pi over 2, we get pi. Divided by 2 would be pi over 2. Okay, what would be the middle of negative pi over 2 and pi over 2? 0. Okay, negative pi over 2 plus pi over 2 is 0. Okay, And then we need the middle between pi over 2 and 3 pi over 2. If we take pi over 2 and we add it to 3 pi over 2, we would get 2 pi divided by 2 is pi. Now we can draw our curve. Okay.
No, Max look at me because I was coughing.
I was joking.
Okay, our sine curve starts at the starting point, but we have a reflected graph, right? Okay, you know what? I'm going to do this in red. Okay. So we start at this point. We have a reflected graph, so it's going to dip down and then come back up for our S shape. Now, what I'm going to ask you that you do is you go back in and you label all of these coordinates. So this coordinate right here is x is 0, y is 2. This coordinate right here is x is pi over 2, y is 3. This coordinate is pi 4. And this coordinate is 3 pi over 2, 3. And just so you get an idea of where this falls in relation to the origin, here is where your x and y axis would be. Okay, so if you want to draw that in to kind of orient yourself where it is, that's fine. Okay. Now let's go back and talk about our frame. Okay. To get these coordinates right here, we did midpoints, right? Your other option would be to take the period and cut it into the fourths. So what is 2 pi divided by 4? Pi over 2. So then what you could do is you could take your starting point and add pi over 2, and add pi over 2, and add pi over 2, and add pi over 2. Okay? Some of you might like that better, and that's fine. Some of you think better with the midpoint. Some of you might like adding better. So we'll talk about both methods as we graph. Okay. Questions before we try another one? Really, once you get the frame done, it's not bad, okay? But we got to get the frame drawn and labeled. That's the big piece of it. Go ahead and write this one down. Oh, you know what? We're going to have to come back. I forgot to talk about something. Billy, Mrs. Homan? Domain and range for sine and cosine graphs, easy. What's the domain for any sine graph? Okay, it extends forever in both directions horizontally. So all the time, if you have a sine curve or a cosine curve, the domain is all real numbers. Okay. Now the range is fairly simple to identify because of our frame. Our frame vertically is drawn from 2 to 4. So our range is 2 to 4. Now, I know that we only have one period of our curve drawn on here, but we need to imagine that this is going on forever in both directions. However, I'll only ask you to identify a period. Okay? But we'll still say that the domain is all real numbers. Kind of like we never really draw the entire parabola, do we? We draw a few coordinates and call it good. Okay? All right, so sorry. Back to this one. Go ahead at your pod, identify amplitude, period, and starting point. Guy, what's our amplitude? Okay. The period. Sydney, what'd you get?
I got 2.
2 for the period. 2 pi divided by b. Okay. If b is pi, 2 pi divided by b would get us 2. All right. And then our starting point. The starting point for our graph, Riley P., what do you have?
-1/3.
-1/3, -2. C over B, comma D. Any questions or disagreements about any of those values? Okay. So our starting point is -1/3, -2. Okay. I know that cosine does not start in the middle of our frame, but we still call this the starting point. Okay. When we construct our frame, how far up are we going to go? Okay, so if we begin at -2, then we've reached 0. And if we go down 2, we've reached -4. Okay. Then we're going to draw our frame so that it has a length of 2. Well, we start at -1/3. Where would it end? What'd you say? 1 2/3. So 5/3. Okay. The period is length 2. So when we start at -1/3 and we add 2, we get to 5/3. Okay. 2 different ways to figure out where these quarter marks are. We could use midpoints. 5/3 plus -1/3 would get us 4/3. 4/3 divided by 2 would be 4/3 divided by 2, right? Okay. -1/3 plus 2/3 would be a 1/3. Divided by 2 would be 1/6. Okay. 2/3 plus 5/3 would be 7/3 divided by 2. 7/6. Now, if you need to make some notes in your margin about these values, that's fine. If you need to do some addition, okay? But you're not going to have a calculator for these. I need to stress that. This is a non-calculator thing, okay? Second method, if our period is 2, if we cut our period divided by 4, that would be 1/2. So you could take -1/3 and add a half. 1/6 and add a half. 2/3 and add a half. 7/6 and add a half. And that would get you those values. Either way, you're working with fractions. You're going to have to get over that. Okay? But now the hard part's over. Okay? Now we can draw our curve. Now we have a cosine curve. Where does it begin in our frame? Up here at the top. And then each quarter mark okay, so when I go to label these points, I know that this is x is -1/3, y is 0, x is 1/6, y is -2. Here, x is 2/3, y is -4. Here, x is 7/6, y is -2. And then up here, x is 5/3, y is 0. You don't have to draw this, but I'm just going to draw in our x and y axis. So you can get an idea of where we are. Okay. Everybody, what's the domain? Okay, we're going to try that again. Everyone. What is the domain?
All real numbers.
Thank you. Turn to your neighbor and tell them the range. Braden, what's our range?
0, -4.
Make sure you put, I'm just going to put -4 first because it's smaller. Okay, make sure you put brackets because we do have coordinates at those places. Okay. All right. I'm going to give you about 5 minutes to identify starting point, period, amplitude, and get your frame drawn and as much as the graph as you can. Okay? Identify the three items and get your frame drawn. If you have time to graph it, awesome. But I'm going to give you about 5 minutes to do this. I am fine with you working together at your pod. You want a little bit of support.
You have like a line where it was.
Okay, does your amplitude period and starting point match mine up here?
Yes.
Yes.
Okay, so when I draw my frame, up here, we have a y value of, and down here we have a y value of. Okay, amplitude 4, up and down, okay? Okay, this is one where I would say, well, either method is really okay, but let's do that second method just so you can get an idea of how it would be done before. What's the period cut into 4? Pi over 4, right?
Yeah.
So what's pi over 4 plus pi over 4?
Pi over 2.
What is pi over 2 plus pi over 4?
3 pi over 4.
What's 3 pi over 4 plus pi over 4?
Pi.
And then pi plus pi over 4.
5 pi over
5 pi over
5 pi over 4. Our curve would then fit in here like this. Where our coordinates are pi over 4, 0, pi over 2, 4, 3 pi over 4, 0, pi negative 4, and 5 pi over 4, 0. Tomorrow you will have a 2-question quiz.
Oh, kill it, guys. 2 questions.
Okay, what do you think those 2 questions are going to be?
Cosine and
Graph a sine, graph a cosine. That's not rocket science.
Crushed it.
Okay? So how important is your homework to prepare for that quiz? Okay? I will go ahead and post, listen please, I will post my solutions to the homework so you can see my graphs. In the back of the book, they'll just have curves with like multiple periods. Okay? They don't have the starting point and whatnot. So I'll post my graphs so you can compare your frame to my frame.